Hi friends, welcome to #TechieMit. So good to see you after a long time. So after a month's break, so we'd like to continue on the multi-threading series. So to bring you new video on Executor framework in Java. So before starting the videos, just do keep liking, commenting, and subscribing to #TechieMit. So let's deep dive into the Executor framework in Java. So starting with the introduction, Java Executor framework is basically a concurrency framework that is used to run the runnable objects without creating new threads every time and promoting thread usage. So basically, Java Executor framework is a concurrency framework, and it's used to like create the runnable objects uh, without creating new threads. Means in short, you achieve thread reusability with the purpose of Java Executor framework. Now let's see further. They come under the package of java.util.concurrent. It consists executor interface, which provides set of factory methods to create thread pool of worker threads. So basically, executors it consists of executor interface, and they basically provide a set of factory methods to create thread pool of worker threads. So a lot of thread pool of worker threads can be created. Uh, Using the executor interface, and we'll see in detail what is the executor interface and some real world examples here. So the number of executor factory methods are as follows. First is the single thread executor. Note that they can be created using the executor interface. A single thread executor, as the word suggests, it is used to create a single thread pool by calling static new single thread executor. So you have to using the executor interface to invoke the new executor service, executors dot new single thread executor, and after that a single thread would be created. After that we have schedule executor. It's used to when we have tasks that need a longer or at regular intervals. So there consider some such a situation in which some tasks need to be executed at regular intervals. Uh, like it may be like a schedule some trips of a bus. They are scheduled for a day, and so you can organize that using the schedule executor. And there are at certain fixed frequencies, the bus route will using the schedule executor. You can create such examples in which the task is specifically executed at regular intervals. After that, we have fixed thread pool. It's fixed thread pool of a number of. If the fixed thread pool of fixed thread pool consists of more, then we use link blocking queue. So if there are fixed thread pool number of thread, then it introduces a linked blocking queue. So the thread pool is converted into a link blocking queue in the case of fixed thread pool. After that, we have cached thread pool. New threads created if existing are not there, and if they exist, we can use the re-existing thread. Means cached thread pools can be used when to create new threads if existing threads are not there. If they are not there, we can use the existing threads. Let's see Executor Service Framework. So it extends the Executor framework with lifecycle management methods. So yeah, the Executor frameworks is there with lifecycle management. Basically, group of thread objects shut down. This method shuts down after finish executing all the threads and it terminates. So basically, if all the threads are executed, then we can invoke the shutdown methods. It can be considered as a lifecycle method in which after invoking the shutdown, all the threads are terminated. And shutdown now, this method abruptly stops stop tasks and cancel abruptly executing tasks. Don't execute new tasks and return unexecuted tasks. Means shutdown now shutdown is like a graceful shutdown, means after executing all the tasks, they ultimately terminate using the shutdown. Shutdown now is like abruptly or like in between, it just terminates at the current stage, and it just return the task they are executed, or also it returns the unexecuted task. After that, we have future interface. So yeah, this is the main important concepts, it's written the result of asynchronous computation. Yeah. So it's a concept in which there is a situation like over a period of time, like you want to achieve some like, task needs to be executed. So that can be done with the help of future interface, and it's not that in a sequentially it should be executed. It can be executed in asynchronous manner, not in synchronous manner. But it's basically use the help of future interface. Methods are provided to check if the computation is complete. Yeah, as you know, there are methods to provide the methods are complete and it returns the result of the computation. The result can be returned only when the computation has completed blocking, if necessary, until it's ready. Cancellation of this can be done by using cancel method. Yeah, so basically that was about the executor service framework. So it's about using the PPT, the example of of the executor framework in Java. So now let's see a real practical example, and we'll see through the example through the Java code. So this is the that has taken in program to demonstrate new single thread executor. So yeah, so we'll make the use of executor service, and we'll create an executor of that, and we'll first import it. New executor service. Yeah, no, it's from the java.util.concurrent.executor service. It's from that package only. So I have to create executors on this new single thread executor. Yeah. So using the executor, it's basically a factory. It's a factory and utility methods for executor, executor service, and schedule executor service. So from this we have invoked this method, and as the name shows, it will create a single thread. Firstly, we'll use a Java code for it. Submit, and as I told that it would be a Java code. Yeah. So we'll type something over here. Task like new single task was starting. Yeah. Yeah. In between, we'll handle this with a try catch. To catch the interrupted exception. Yes. So time unit Suppose we'll leave this particular for 2 seconds. Interrupted exception caught for task 1, and like this would be like one task. So similarly we'll investigate for at least 4 tasks. One, this comment out here, task 1 submitted, task 2 submitted, task 3 submitted, and we'll just increase in task 2, task 3. You note we have changed the like timeout. See, time unit dot sleep dot second. It is also from the again the same package java.util.concurrent, and this is a class, and you can specify it in the seconds, minutes, hours. So we have specified 2 seconds, and we have entered an exception for it. After that, this would be like 4 times. Let's go to 4, 4, 4. This is done. After that, if all the tasks are executed, so finally it will shut down, shutting down that executor. And now this is done. So just we have created a single thread executor. We have on that executor we have using the Java 8. We have submitted using the submit method, and it contains the code and that will execute for like each of the tasks. And we are also handling the try catch using the try catch exception, and there is likely a shutdown method. And what this is shutdown, as we saw on the, it will like gracefully shut down after completing all the tasks. So let's see if it executes as well as discussed. Run as Java application. New task, single task 1 is starting. New single task 2 is starting. New single task 3 is starting. New single task 4 is starting. Correct. Yeah. Now, just for our purpose, we'll after the shutdown is done, we'll also give a print statement that all tasks executed successfully. So that as we will come to right, gracefully shut down and all tasks are executed successfully, submitted successfully. See, here use task. And note here, it's like abruptly printing because after first task, after it abruptly print this, all tasks are submitted successfully. But this is not the expected output that you want. Now let's see how we can rectify this. We will not. So like we'll change this for 5 seconds. Now this is the situation if it's not gratefully shut down. So executor dot shut down now it will do, and it will catch this interrupted exception ex that instead of print status will give this as sysout and we'll see this can be caught or not. That's in uh, shutdown now catch block exception caught. So this will handle if like abruptly if any this terminates, it will abruptly terminate and it will return all the non-executed tasks. So we will have shutdown also, graceful shutdown in the task, and after all the tasks will shut down, and it will print if any like error doesn't occur, it will ultimately print all tasks are executed submitted successfully, and if abruptly anything is terminated, then it will get this exception. Now let's try to print this output on the console. I'll clear this. Let's see what it prints. No, note here. I will just change the time in some seconds. First, I have given 2 seconds. After that, I have given us 1 second. After that, again 1 second. After that, I have given us 3 seconds. I will make this 3 seconds. Okay. Now let's see what output it prints on the console. New single task. This is executing. Second also executing. Third also executing. Fourth executing. All tasks submitted successfully. But yeah, after that it gives this exception. Interrupted exception caught for task 4. So because this condition we have to await terminate blocks all until all tasks have completed execution after shutdown request or the timeout or the current thread is interrupted, whichever happened first. So we are getting this exception not because the all the tasks some of the tasks abruptly terminated. It's because all the tasks have completed the blocks until all the tasks have completed execution after shutdown request, and also we have the shutdown request. So ultimately after all the tasks executed and we got the shutdown request, and after that we got this exception. So, yeah, so this is the importance of await termination. So like maximum time to wait, if like you can consider scenario in which you will wait for some maximum time, and some exception needs to be thrown, it can use the await termination. So like 5 seconds it waited and it allowed all the text to be executed, ultimately thrown the exception. So this video was all about this new single thread executor demo, in which we saw that how using the executor service we create the executor here, and like how using the submit we can execute our code and we can pass what code needs to be executed, and ultimately we invoke the shutdown method, and in what case await termination can happen, and what we can do over here. So do keep liking, subscribing to #TechieMit. More to come on in Java related stuff and multi-threading related video. Keep liking, subscribing. Stay tuned. Bye for now.